Okay, hi, I'm Denise, and this is a brief video on very basic chemistry concepts that you would need for the nutrition class. And so I just want to give um, a warning. That's not the word I wanted, but I'm going to give a warning that disclaimer that for those of you who are familiar with science and chemistry, you're going to be super annoyed because I'm not even going to tell you from where the numbers come. I'm not going to tell you about protons, or we're not going to talk about atomic numbers or even the periodic table of the elements. I'm going to say to my students, because you're not all science majors and you don't necessarily need this depth, I'm going to say trust me when I tell you about these numbers. But we are going to talk about electrons, and we're going to talk about some specific elements and look at some specific atoms. Carbon, hydrogen, and oxygen is probably all I'm going to show, but you should know nitrogen too. And what we're going to talk about is how many electrons they have. And people talk about the outer shell, so that would be fine if you know orbitals or shells, but how many they have in this outer layer, and how many they want to be stable. And then from that, we come up with the number that's missing, right? So how many, and that missing number is how many times they'll bond. And just to give you an idea of what I mean about stability, if you were trying to build something, and I'm just using the things I have at my desk, so my Pellegrino bottle. And I wanted to make a stable, I don't know why, I'm building something, and I wanted this to be stable, but I only had one Pellegrino bottle. You could see where this isn't very stable, right? Like there's just not enough support here, and this thing just keeps falling off. Okay, so this isn't stable because there's only one. If I had two bottles, okay, well, hopefully it'll be nicer if there we go. The bottles aren't the same height because one lid is screwed on and one is not. I should have checked that before the video, but you can see that because now I have two, this is stable. This can now hold this up, and there's no, craziness going on. So that's what that's what I'm after here, right? I'm trying to create atoms that are stable, and the ones that we're looking at are going to be missing electrons. And by finding these electrons, we can create this stability. So I just wanted to give you that idea of what that means when we talk about stability. So we're going to start with something super simple. We're going to start with hydrogen, which is as simple as it gets. Hydrogen is actually the first atom on the periodic table, and it has one, that little hole, those are our electrons, okay, those represent our electrons. And that hydrogen has one. That's it. Okay, and in order to be stable, like a noble gas, like helium, it needs two. It needs two of these little electrons, but it only has one, and it can't, just out of thin air create another one. So it has to find a way to get the other one. And the easiest way for it to do it is for it to find another hydrogen. Okay, so now I have two hydrogens, and they each have one electron, but what they really want is two. And what they know about each other is they know that sharing is a good thing, right? Everything you ever needed to know, you learned in kindergarten. Sharing is good. And so these hydrogens know that if they can get together and they can allow these electrons to come into each other's space, they can share them. And so that's what they do. And that's called bonding. And that bonding, when you share, is called covalent bonding. And it looks like that. It creates this little bond in between that holds these two, creates this like force that keeps these two together, and now they're stable. There's no instability, right? One Pellegrino bottle or two Pellegrino bottles. And that is the most basic of the structures we would look at. Oxygen then has two electrons that don't have a pair. Okay, now some of you are like, Denise, that is not how many electrons oxygen has. It has 6, and then the 2 inside, and so it has 8, and then it's missing 2. And yeah, I know that. You know that. But they don't know that. And they might not know that. And Buddy, he definitely doesn't know that. So let's not worry about that number, right? We're going to keep it simple. And I'm just going to say to you that oxygen has 2 unpaired electrons. All the other electrons on this are have a pair. So the easiest thing to do, except I dropped it on the floor, but I have more. The easiest thing to do is for this oxygen to find a hydrogen. Now these each want to share. And so these can say, I'll let you borrow my electron if you let me borrow your electron. And we're going to build that right now. What that would look like if I had the Pellegrino bottles is maybe if I had a whole bunch of them and like a couple of them balanced on one bottle. All right, and so then we made this molecule that you all know, and it's what the majority of your body is made up of, H2, 2 hydrogens, O, oxygen, and we made water. And that's because the electrons are sharing, and that sharing is shown by that little plastic in between the bonds. Okay, carbon, I will give you carbon. Carbon has 4 unpaired electrons. You're going to have to trust me. There's 1, there's 2, there's 3, and there is 4. Those are the 4 unpaired electrons. This, by the way, is not high quality video. Got my vacuum in the background, whatever. So can you in your head already think, oh, 4 unpaired electrons, and each hydrogen has 1. So how many bonds, if carbon is going to bond only to hydrogen, how many hydrogens do you think will bond with the carbon? And if you said 4, then you got it, right? Each of those electrons, each one of those little holes that was, let's see if I can get all 4 of them. There, you can see all 4 of them now. Each one of those holes that was an unpaired electron shared with the electron of hydrogen. So that is single covalent bonding, and we are going to see molecules get put together and molecules get broken apart, anabolism and catabolism, when we get into metabolism. But you're also going to see something else. Let me get an oxygen again. You're going to see another thing in lipids, and we're going to talk about saturated and unsaturated fats. And that's just talking about something called double bonds. And so let me just show you what a double bond is. If I have an oxygen and it needs to bond once, twice, okay, you see that? Oh, there it is. What that oxygen could do is bond with another oxygen that bonds once, twice. Now, that would be a single bond. They would be sharing these electrons. But the problem with that is they each have an electron that is still unpaired. Now, if they could find some hydrogen or something else in nature, they probably would. They prefer to have these single bonds. They're the most stable. But in the case that that doesn't happen, these two could say, well, you know what? Whoops, I got the wrong one. Find a longer one. These two could say, hey, sorry, I'll be right back. Okay. These two could say, what if we bond twice? And so now what we have is what's called a double bond. This electron sharing with that electron, this electron sharing with that electron, and everyone is now happy and complete and stable. We've created stability. And this is what a double bond looks like, and that's going to come up in saturated fats. Now, we're going to be looking at molecules that are very long and kind of complex, like, you know, something that my kid made. All right? I don't know what this is, and it isn't whatever it was because I destroyed it to get some of the items I needed. But that is covalent bonding, and it's a little different than ionic bonding, which actually is a little bit more simple. That a sodium might say, hey, I have an extra electron, and here, chlorine, you can just have it. Here, you can just have it. So it looks different. It's not that shared bond. It just hands it over, and then they hang out together. That's ionic bonding. So in ionic bonding, it's not that kind of sharing that they're going to stick together and share the electrons back and forth. In ionic bonding, the atom says, "Here, you can have my extra one because I have too many, one too many." But then they still stay next to each other, like in salt. So that's the difference between ionic and covalent bonding. Covalent bonding seems to be the most challenging. So in the reading of Appendix B, that's really what I want you to be familiar with, covalent and ionic bonding. You don't have to go beyond that, but you might read a little bit before if you want to get some of the background information. And I hope that helps. Otherwise, Khan Academy, lots of science channels that have good visuals of what this looks like. So keep digging, and eventually it'll click. Eat well, play fit.